Hi, and welcome to our demo video around a Dell container storage module called Replication between two PowerFlex arrays. Let's first look at the topology. So we have our left and our right data center, and in both data centers we have a separate cluster called Kubernetes 04 and Kubernetes 05. Also, we've installed the Dell PowerFlex CSI driver at both sites, allowing us to access the two PowerFlex units we have in these data centers called PF02 and PF03. Additionally, we have enabled replication between the two, allowing us to install the brand new CSM replication module for PowerFlex as a sidecar within these clusters as well. So that basically concludes the topology that we have, and it allows us now to deploy an application on one data center, have it replicated to the other site, and ultimately fail it over. So let's look at the actual demo environment. As you can see, we have two standard vanilla Kubernetes clusters with a single control plane and then 3 worker nodes. At the moment, we don't have an application running just yet, but in a second, we'll be deploying the Yelp application, which is a small microservice application that uses persistent storage. So speaking of persistent storage, let's look at these two systems, right? The two PowerFlexes. So as you can see at the moment, there's 0 volumes here, 0 volumes there. There is no replication consistency groups defined yet. And basically it is sitting here ready to go. So let's deploy this Yelp application. Very simple. I just create some stuff using this piece of YAML code. And there we go. So now if I say get me the PVC, you can see that yes, 2 PVCs were created, one for SQL, one for Redis. And when I look at the pods, you can see, oh, this one is still creating. Let me refresh. Yep, we're up and running. You can see there's a Redis server, an app server, a database server, and a UI server. So in order to get to this application, all we basically need to know is the IP address we can grab from here and the service port number. So get me the services. Right, so when I basically take this IP address and then the port number, I can basically go into a browser, specify the correct IP and the correct port, and there we have our little Yelp app. As you can see, this is a small voting app, and as I'm casting votes, you can tell that it has access to the persistent storage layer because it actually manages to store all of my votes inside the data center, then report that back on the website. So right now I have 10 votes in here, and I guess the next thing that we need to do is, well, let's first look at what this looks like from a storage perspective. So if I go into both PowerFlexes, I can see that 2 volumes were created. So these 2 volumes are actually the two, so the Redis and the SQL volumes that actually make the Yelp application work. But as you can see, there's also an RCG created. And this RCG actually replicates from PF2 into PF3. Now, when we go into PF3, you can see that there's 2 volumes here, like the same one here, only they are front-ended by this replicated piece of tagging. So you can actually see that it's already created replicated volumes on the right data center as well. So if we go back, we can actually tell that because what replication also took care of is, obviously we don't have the application running on the right data center. We don't have any PVCs, which I should get. But there are 2 PVs already created, and you can see that these PVs are already there and basically almost ready to go. So if we want to fail over this application to the right data center, all we need to do now is somehow get the PVCs recreated. So in order to do that, we need to be able to talk to CSM replication, and we do that through a tool we call repctl. in order to use that, first I need to actually know the replication group ID. So I have a single replication group ID here. So this is what's being used to actually replicate my little Yelp app to the right data center. So if I now use repctl and I can say, get me the PV from this cluster, you can see that it knows actually way more than just the PVs, right? It knows the original PVC names, also the logical names, right? Which is Redis1 and SQL. It knows the namespaces it was running in, which is default. So if we want to like recover, all we need to do basically is break and reverse replication. After we've done that, we can actually create or recreate the PVCs and get the app running on the other side. So first, let's break and reverse replication. We do that by doing repctl, and now we need to specify this specific group we want to apply this to. And then we should say that it needs to fail over, and the target cluster should be Kubernetes 05. There we go. So that's basically failing over. And now we can actually reverse replication as well by specifying the same replication group. And now we're going to say reprotect at Kubernetes cluster 05. Right, when we look at this from a storage perspective, and so right now, if we look into the RCG, we will see that yes, replication was actually reversed. So now we are replicating from PF3 into PF2, which is the other way around, right? So we're going from the right data center now, replicating into the left one. So now the time has come to actually say repctl and create the PVC or recreate the PVCs on this side. We need to specify the correct group again, and also we need to tell it which cluster that we should apply this to. Don't forget to specify the namespace, which will be default again. There we go. It asks me to proceed with the creation of the PVCs. Yes, please do. And right now, if I do a get PVC, you can see that, yep, there we go. There's our two PVCs now being recreated, bound already, ready to go. So all we need to do now is basically to create the application on this side, and I'll just use the same piece of YAML code to recreate it. The warnings you'll see is because the PVCs were already there. And of course, that shouldn't be a problem because that's basically exactly what we want. So in order to look at the recovered application, we need to do like a similar thing again. And we need to like get the node's IP address, and then we need to get the service on this side. And now we can actually just grab one of the IPs here. And then when I go into a window on the right data center, I can actually go there, and then I can say, well, just get me the correct port number. And there we go. You're now looking at the recovered Yelp application. So as you can see, data was successfully replicated to the other side because we still have our votes. And you can see when I press the voting buttons that I can actually still vote, meaning I do now have read-write access again into the replicated volume that is now being replicated to the left side. And I could repeat the same thing in order to fail back if I wanted to. So this concludes today's video. Thank you for watching and stay tuned for more from us. Bye-bye.